In this video, we're going to talk about how to find a range of a function. So let's start with a linear function, y equals x plus 3. The first thing that I would recommend doing is graphing a function. So basically, this graph is a straight line graph, but shifted up 3 units. So the y-intercept is at 3. So this is a rough sketch of the graph. Let's do that again. Now, this graph keeps on going forever in both directions. To analyze the range, you need to look at the y values. The lowest y value that this could be is negative infinity, and the highest y value it can go all the way up to positive infinity. So the range for any linear function is going to be negative infinity to infinity. So if you see the leading coefficient is x to the first power, this is going to be the range. Now what about y equals x squared? So if the leading term has an even power, the range won't be negative infinity to infinity. It's going to be limited. So this is basically a parabola that opens upward. As you can see, the lowest y value is 0. The highest is infinity. So the range is going to go from 0 to infinity. We need to use the bracket symbol to include 0. But you should always use a parenthesis when dealing with infinity. Now let's try some other examples. Y equals x squared minus 3, and also y equals 4 minus x squared. So once again, for both of these, I recommend graphing the function. So for the first one, it's going to be shifted down 3 units, but it's still positive x squared, which means that it opens in the upward direction. So the lowest y value is negative 3, the highest is infinity. Thus, the range will be from negative 3 to infinity, but it includes negative 3 because if you replace x with 0, y will be equal to negative 3. Now for the next one, it's shifted up 4 units. So it's going to start at positive 4, but notice that we have a negative sign in front of x squared. So this means that the graph is going to open in the downward direction. So the lowest y value is negative infinity because it keeps going all the way down to negative infinity. That's where the arrows are pointing. And the highest y value is 4. So the range is going to be negative infinity to 4. Now what if you have a quadratic expression that looks like this? Let's say x squared minus 4x plus 5. What would you do in this case? Now, since it's positive x squared, you know that the graph is going to open in the upward direction. What you really need to do is figure out the y value of the vertex. So to find the x value of the vertex, you could use this formula. So a is 1, b is negative 4, c is 5. So it's negative b, that's negative of negative 4 over 2a, and a is 1. So x is positive 2. Now that you have x, plug it back into the function to get y. So it's 2 squared minus 4 times 2 plus 5. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. Negative 4 plus 5 is 1. So the vertex is at 2, 1. So now we can draw a rough sketch of this graph. So all we need to do is plot the vertex. Once we have that, we know that it opens upward. So we can see that the lowest y value is 1. The highest is infinity. So the range is going to be from 1 to infinity. The next thing we need to talk about are the cubic polynomials. The graph y equals x cubed looks like this. As you can see, the lowest y value is negative infinity, the highest is infinity. So the range is going to be like this. So if you were to see a cubic polynomial, like let's say like something like this, or even something like this. This is not cubic, but I want to show you something. Notice that the leading term has an odd exponent. When you see that, the end behavior will always vary from either negative infinity to positive infinity or the other way around. So the range is just going to be the same, negative infinity to positive infinity. Now in the middle, it might vary, but the end result is still the same. These are continuous functions. So what you need to know is you need to know how to graph functions, because if you can graph the function, you can easily find a range. Now let's move on to absolute value functions. go ahead and graph the following absolute value functions and determine the range. So for the first one, this is simply going to form a V shape. So the lowest y value is 0, the highest is infinity, so the range is going to be from 0 to infinity. For the next one, it's going to be shifted up 3, but it's still going to open in the upward direction. So it's going from 3 to infinity, and so that's going to be the range. For this one, it's been shifted 2 units to the right, and it's been shifted down 3, but it's still going in the upward direction. So it's going to look like this. The lowest y value, we can see it's -3. The highest, it goes all the way up to infinity. So the range is from -3 to infinity. Now the next one's going to be a little different. It's shifted up 2 units, and it's shifted 3 units to the right. But notice that we have a negative sign in front of the absolute value function, which means that it's going to open in a downward direction. So the highest y value is 2, the lowest is -infinity. So the range is going to be from low to high, -infinity to +2. Now let's talk about graphing radical functions. Let's say the square root of x, negative root x, square root of negative x, and the square root of, well, negative square root negative x. So notice that we have a positive on the inside and on the outside. So this graph is going to open towards quadrant 1, where both x and y are positive. The lowest y value is 0, the highest is infinity, so the range is going to be from 0 to infinity. Now for the next one, notice that there's a positive sign near the x, but a negative sign near the y. So this graph, what it's going to do is, it's going to go towards the positive x-axis, but towards the negative y-axis. So it flips over the x-axis going in that direction. The lowest y value is -infinity, the highest is 0. So from low to high, the range is going to be from -infinity to 0. Now for this one, we have a negative on the inside, but a positive on the outside. So it's going to go towards the negative x-axis, but the positive y-axis. So it turns out that it's going to reflect over the y-axis. So it's going to go look like that. The lowest y value is 0, the highest is infinity, so it's going to range from 0 to infinity. Now for the last one, there's a negative sign in front of x, so this is going to go to the negative x-axis, and we have a negative sign outside of the radical, so it's going to go towards the negative y-axis. So it's going to look like this. So relative to the original one, it reflects over the origin. So the lowest y value is -infinity, the highest is 0. So the range is going to be from -infinity to 0. So if you know how to graph the function, you can easily determine the range. So let's say if you have something that looks like this, the square root of x minus 3 plus 4. And let's put a negative sign in front of it. So you know the graph has been shifted up 4 units. And at the same time, it's been shifted 3 units to the right. So the origin point is at 3, 4. Now we need to know where it's going to go. Either this way, that way, or that way. What would you say? Well, there's a positive sign in front of x, so that means it's going to go this way. And there's a negative outside of the radical, which I like to associate that with y. So it's going to go down, which means I'm going to pick this one. So it turns out that the graph of this particular function looks like this. And if you're not sure, you can plug in points. So if we were to make a table, if you plugged in 3, this would be 0 plus 4, you'll get 4. If you plug in 4 as your next point, you'll have 4 minus 3, which is 1. The square root of 1 is 1, but we have a negative sign, so -1 plus 4 will give us 3. And then the next point I would pick is 7, because 7 minus 3 is 4, which is a perfect square. Square root of 4 is 2, but with the negative sign, that's -2 plus 4, +2. So if you were to plot the points, you could see where it's going. The next one is 4, 3, and then it's 7, 2. So we have the right direction. So we can see that the highest y value is 4. This will keep on decreasing slowly, but it's going to keep on going down all the way to negative infinity. So the lowest y value is negative infinity, the highest is 4. And that will be it for this example.